So I'm just going to bring it up on GitHub and we'll take a look here. So we've got a package here. We have our handler, and this is where the bulk of the Asterisk specific stuff happens. So let me try to summarize it a bit here. Is essentially we have this handle call, which is our, oh yeah, absolutely. This should be a bit better. This handle method is really our kind of, so I have those three parts, which is our observe, analyze, and act. This is really our observe phase, and we're going to look for that CRD, and then we're going to come to this next method, which is I called cycle asterisk pods, essentially because I wanted to look for them. So what I do is I go into a wait loop in a couple places here, and then, okay, trying to figure out where I am. So I'm trying to find all of these. This is my wait looping here. And then I cycle all the different pods, and then I go and I say, all right, here, we're going to use this create SIP trunk method. So essentially, as it cycles through all of these, so this cycles each pod for each other pod. So that's how it winds up creating. So if you've got 4, it's going to take the first one, and then it's going to cycle the other 3 for that one. And then I'll take the second one, and I'll cycle pods 1, 3, 4 for the second one, for example. So it runs through all of that cycle, and then calls create SIP trunk at each point. So essentially what I do is I'm using a HTTP client that's a standard Go library, so it's not like one I had to import specifically or otherwise get from GitHub. It's fine. And then you can see some of the behind the curtains prototype stuff, like I have this insecure authentication to ARI. So essentially what I'm doing is I'm creating this URL that I know which IP address it's on from service discovery. So this create SIP trunk gets called, and we take that, I say target host, it really should be target pod, but that was I think of the host name, so that's what I called it. So that gets inserted here, and we have this, generally our 8088 to ARI on this particular pod, and then I generate a bunch of URLs. So for basically 3 things that we're going to do. I create a test URL where I'm just looking for a positive response from ARI itself to know that Asterisk is booted. And I kind of learned that the hard way because I'm like, just start throwing stuff at ARI. And then ARI was built better than I knew to operate it. And it said, hey, Asterisk isn't booted yet. So I'm like, okay, I better go into a loop and test for that. And then essentially 3 things that I needed to make, which was an endpoint, an identity, and an AOR. So we go through and we go to each one of these points, which is res pjsip endpoint, res pjsip identify, res pjsip AOR. So I wait for Asterisk to be booted, less interesting, and then I say, all right, endpoints here, let's create some JSON. And I say, so some of this stuff, it is hard-coded. So I had this transport UDP that I created by hand, quote unquote. It's part of the container image. And then I have the world's dumbest dial plan. It just says basically for any digits on inbound, wait for 10 seconds or something like that. That's all that the Asterisk box does. So I say use my inbound context. We are going to reference an AOR, and it's the endpoint name. So it's like for the target pod with the other end of the SIP trunk. So that's essentially what we're going to create here. So that if this is asterisk A, create this endpoint to asterisk B. Goes and does that, tries to handle any errors that happen there, and then it creates the identity. So similar kind of idea is, hey, we want to match this particular IP address for this particular endpoint name. So it's this /32 for this asterisk B, for example. Goes and does that, and then it creates AOR, and essentially we're saying it's this user at this IP 5060, and away we go. And that's really all that there was to that particular point. So it's really 3 ARI calls per each SIP trunk that's created. So also, thanks to Matt's blog articles about how to use push config, titled "Push It Real Good," I believe, and I referenced that over the last couple of years. I have definitely referenced that article a good half dozen plus times. I think that I probably copy and pasted it in wholesale into my code a few times to just be like, all right. Let me see, let me poke at it with curl, and then I'll actually like put it in and use it in my thing here. So I can be like, okay, let me take apart the curl thing and be like, okay, cool, this is actually a smart REST application. It uses proper methods. Can I do that? Make sure that I'm sending it JSON and all of that good stuff.
This could be more of an ARI question, but after you push this in, this is understanding it's in a database now at this point, right?
So, yeah. So
the point was like, do you need to rip this back out then if you're going to take down that trunk or,
So before we go too far, can we try to either repeat the questions or use the mic, if at all possible?
Yeah, go ahead.
Yeah.
We can just hand it around. I don't know.
Okay. This might be more of an ARI question, but as you're creating these trunks and anything basically through the ARI like this, one, is it stored in the database or not? And then two, like if these trunks are you're gonna take one away, do you need to delete those out? Or if you're just like getting rid of a couple of these servers and they go away, do you need to clean that up or?
Can I answer? Yes, thank you, Matt.
Please do.
Woohoo! So it all depends on your sorcery conf. In sorcery, when you push through ARI, all it's really doing is going in. It's like a mapping directly from the HTTP interface back into the C API for sorcery, and just tell sorcery, "Hey, I got this JSON payload. Can you go create that?" Sorcery will determine, based on what you've configured there, where it actually stores that. So if all you have is file, for example, you'll actually get an HTTP error that says, "I can't create things. It's a static file." If you backend it with memory or ASDB or a real-time driver to go try to store it in whatever you told it to go do. So your persistence then is also based upon which backend storage you've chosen, right? So if it's in the memory and you restart Asterisk, it's all gone. If it's in, I used ASDB for most of the stuff though, when I was actually building this, like testing it out, and just because that way if Asterisk restarts, it does its thing, but any of them should work. To your point though, you know, there's implications for when you destroy things. You probably do need to clean things up unless you've got it in memory. But keeping in mind that when you destroy certain things in PJSIP, that may trigger other stuff that may be exactly what you want to have happen. So for example, with an outbound registration, if you destroy an outbound registration, it should, I think, send an unregister as well, because you just nuked the outbound registration. So you will unregister your trunk when you destroy it as well, which is probably good, but it also might be depending on what you're trying to do there.
That is an awesome answer and way more detailed than mine, which was going to be simply, in this particular case, I did not set it, so I'm assuming it's just in memory config by default, because essentially all that I said was enable ARI and set a password.
How does it work?
I don't know.
That's crazy. I know. I thought it would blow up.
That's for an endpoint, right?
This is the ARI conf. So
Yeah, it was pretty sweet that we could just push config in and just have it live in memory, and there is no configuration file.
What's your, oh, so you don't have a sorcery.conf?
hold on, let's see. I don't think I do.
If there is, it's like, not Sorcery.
It'd be,
Sorcery.
Sorcery. Oh, I do. Okay.
Yeah,
But it's all
how
commented
much-
out.
It's a,
but
this
how much
is
of
a
it is?
this is a default sorcery. conf.
huh,
Yeah. So this is a yeah.
I'll be
straight up
damned.
Default.
Yeah, you don't actually need to tell Asterisk anything until after it's already started. You need
So-
just enough config to make it start.
I'm going to give Josh credit for that magically working then, because I don't know actually how it is. It must be using memory in the back end somehow, like a
So,
caching
it
thing
does-
of some
Magic
sort.
Josh
It is
knowledge.
magic Josh knowledge. Yeah, I don't. That's hilarious.
Yeah, and
Yeah, it took a little bit to figure out, but then once I was like, oh, it just does, okay, there you go. You just push it in and just load it into memory, and I don't really care because when that asterisk goes away, it's intended to just go away.
Right.
I don't actually care about any of the configuration because its entire knowledge is entirely separate. It's not part of the asterisk. The asterisk only knows about it because I told it to know about it. So all of that actual knowledge and configuration information is entirely external of the asterisk pod itself. That's what the controller's doing. The controller's telling the asterisk what to know. Who are you? What are you? What are you supposed to talk to? What endpoints do you care about? All of that information gets pushed into it after it's already instantiated.
Another thing I guess I should mention here, and it's certainly in the linked article, was talking about some of the limitations or downfalls of the kind of methodology that I use, and a lot of it is under the umbrella of this is a POC. So some of the
So you can do anything you want.
So you can do anything. You can do anything you want. It just lives in a lab, and it's all in happy, magical fairyland. So it doesn't really magical Christmas land is maybe the way to put it. But generally, there's a few things that are totally a problem, and probably garbage collection is one of them. So I'm not sure if you scale the cluster down. I think it might leave behind SIP trunks that are invalid, so that's one thing. Another thing too is that it's totally brute force, so it just makes the calculation of the whole universe of what it knows every time, and it creates all of the SIP trunks. So if you spun up 30 Asterisk instances, and then you went to add a 31st, instead of it just creating 30 SIP trunks for that one extra box, it's going to create the whole shebang, which is crazy inefficient.
But easier to program for a POC.
Yeah, it was, but yeah, for this particular case where I'm like, all right, I want to show it, and then I want to show it grow by one, it was very small, but in reality, you probably...
Sorry, just open a story in Jira and let someone else do it.
Yeah, yeah, exactly. Yeah, patch is welcome.
But yeah, I really like the idea of being able to just push the configuration into Asterisk and not really have to have it know anything ahead of time.
Yeah, we really enjoyed that.
Yeah, that was
for
pretty
sure.
sweet. Matt's like, I didn't know it did that.
Well, the memory one, I didn't know that. So here's,
You have the mic in your hand.
Okay, just want to make sure because I don't want to
Yeah.
dominate or anything. So here's something that actually, because I was doing push, I wrote push config, so I was using it for a lot of things for a while there, and I actually backed out from one particular part of it because we were doing a bunch of lab things and it was really great, and then something actually was a practical consideration that actually caused me to rethink at least part of it, and this might be just something, I'd be curious your guys' opinion on it. With a lot of stuff, it was very handy where when we had endpoints that we wanted to be represented on all Asterisk instances, which is generally the case if I want to keep my SIP proxies very stupid so that they can just load balance everything across, right? In which case, their configuration of those endpoints that I was actually allowing to be represented in the Asterisk instances, I would have to go push them into each one every time somebody needed it, so because they all need to know about it, because my routing is just round robining. So in that particular case, there were some endpoints we did with push config, and then some endpoints I actually ended up backing with a database in a very traditional sort of way. And it mixes and matches, but it was interesting because initially I had it all in push config, and then I found I was just looping over Asterisk instances and dumping things like all the time, and it ended up being like more effort than it was worth.
I am gonna guess that in most realistic use cases where you are using push config, you're gonna have some limited amount of static configuration for stuff. I think that that is probably just a real world thing, is that, hey, yeah, a lot of stuff is dynamic and it's cool when it's dynamic, but there's probably gonna be stuff that
Yeah, like
just
maybe your
doesn't
SIP
change.
trunks are a little bit more like static, because you're not changing providers every 30 seconds, probably. Likely.
Yeah.
I mean, you might change your weighting, but you can do that totally independent of Asterisk, where Asterisk sends it to your Camellia or whatever, and it does all the weighting to the outbound, or it does all the checks and stuff. And you kind of externalize that logic. What you're probably more dynamically adjusting is adding, sets, handsets, endpoints, ability to spin up new instances for new tenants, scaling those up and down dynamically. That kind of stuff is probably more for your push, and if it's not the most efficient, maybe it doesn't matter so much. But yeah, like every time you add one, having to go to all of them to push the same configuration, that's effectively probably not going to change very often, and if it does, you're just like, whatever, I have to reload PJ-SIP across all my instances at some point.
Yeah, I think that's a good example. It's like, hey, maybe your considerations for least cost routing change, and those are a bit dynamic, but I would imagine with the amount of paperwork that the real world requires for adding new ITSPs, that probably dynamically adding and removing ITSPs probably
Might be a little overkill.
A little rare, and hopefully, happens in like one sort of layer of your platform, like at your network edge or whatever.
Yeah, and
right?
if you're dynamically adding them in and out because you want to be like, oh, that one's not available, or this one is available, or I want to change the routing stuff, like maybe your approach is just wrong. Maybe you're not doing it at the right spot.
Or you're a really bad person.
Entirely possible.
Also possible.
You
Yeah.
could be a very bad person. It is possible.
All right, cool. So that kind of covers this part of the code, which was a request. If anyone wants to look at anything else there, that's fine. I know I'll take any other requests. There was also a diagram that.
Oh yeah, I had a diagram I wanted to go over. Just to follow up on okay, so I have APBs and operators, now what? Where do they go? What uses what type thing? So this is early. This is my kind of interpretation right now. So you'll notice the question marks kind of peppered throughout this diagram because it's still effectively a work in progress. I need more information is what it comes down to solidify this. And this diagram has already changed 3 times in the last week once I built it last week. So I've been trying to think about these things in layers and who owns what at what layer type thing. Like whether that's teams or project management or just logically separating it out. So you kind of have your platforms at the bottom. You have your OpenStack, you have your OpenShift, you have your bare metals, you have your your RHELs, all that kind of stuff, right? And then you have things that run on top of that. You'll notice I have OpenShift significantly larger here because this is really what I'm trying to really think about. The OpenStack stuff is a little bit more figured out. So where does an operator exist, and what happens when I start building more complex applications that leverage multiple operators, and how do I bind all of those together? So you have your application components at the next layer, which they're containers. That's what I mean by application components. They're your container images that are instantiated as containers. Then you have your operators, and typically you're going to have an operator per application component. So You're going to have your Asterisk operator, you're going to have your Homer operator, you're going to have your Nginx, your MongoDB, your MySQL, all of those types of things, right? So each of those are pretty much going to worry about the lifecycle management and instantiation and teardown of the of those particular application components that they've been built to deal with. So that's great. I now have multiple operators for multiple applications, and all of those operators are able to understand kind of their niche, their little bit of information, right? And so there's a thing that's being built now as part of the operator SDK. There's an operator lifecycle manager. So the operators themselves are containers, and themselves also need to be lifecycle managed, because as I add more functionality to my operator, I need to be able to upgrade the operator itself so that it is able to provide more knowledge and more application component orchestration to those pieces, right? So the operator lifecycle manager is kind of there to own all of the operators at that level, so you can run multiple of them and deal with kind of rolling over to new versions and deploying those operators themselves. So what of VNF Asterisk, and what if I am taking multiple operators and combining them all together? So I kind of have this thought, and some of this may fall into the operator lifecycle manager. I need to read a lot more about this. Some of it may be handled here, some of it might not be. Some of it may be fronted where this application, what I'm calling an orchestration operator, really talks to the operator lifecycle manager via an API. I'm not sure how this is all technically going to go together. But logically, I see kind of an orchestration operator that, so for example, what that orchestration operator would do is once you've got all of your operators up and running, what it would be responsible for is actually creating the CRs, the custom resources, so that those operators can create the application components themselves. So just like in Doug's Asterisk operator, we have, once he instantiates the operator, and once the CRD exists, there's no objects, there's no asterisks, nothing exists at that point, right? So now I have to have something that says, okay, I need something to create the CRs. Well, I could obviously go and write OC apply-f or kube control apply-f, and just like he did, and actually create the YAML. But what would be nicer is if I had an application that kind of dealt with that for me. Maybe this thing is even fronted with a UI or something and creates some of this, nicely. This is the application itself, and all of these operators are just components that make up the business logic and the actual application. So then what it can do is it can operate and say, okay, I need to create a new instance of this tenant. And so that could be a CR. And that CR could be kind of a combination of all the things that all of those operators need to know, but maybe in its own CRD that's like kind of a little more flattened and maybe matches your business logic a little bit more than the technical logic of how all those operators work. So now when you create that CR and the orchestration operator goes across, it says, okay, instantiate an asterisk, and then go and write it into, also find its IP address, and once you find the IP address, write it into a database. And now that that entry is in that database, go to your Camelio and reload the distribution module so that it knows about what asterisks exist, right? So this orchestration operator kind of operates against all of the other operators, creating maybe some CRs, maybe doing entry into databases, maybe reloading modules, all of those operational things that maybe you can't build directly into the specific application component operators, because I don't want my asterisk operator to be biased towards what database it's going to use and how it's going to interact with that database. Because then all you end up doing is building all this functionality that's really should be at an application layer directly into these components and making them significantly more complicated and junky than they really need to be. What I want the operators at the operator kind of level there at the third band is really for them to be, to a certain degree, dumb. I want them to just care about that application component and just care about dealing with it and really knowing how to deal with them really well. but then let this kind of orchestration operator, which is really my application, deal with all the things across all of the operators and what orders they need to go in. So, oh, I tore down an asterisk. Oh, I need to go and remove entry out of a database, and then I need to go reload a module. Or, oh, I'm changing from version 14 to 15, and the database schema needs to change. So then I need to back up the database and change the schema, and then update my asterisk and roll it over to a new version, and then reload modules over here and things like that, right? So all of that kind of orchestration across lots of components all together, and how I want to manage that really should be kind of out of the purview of the individual operators themselves. So then, okay, so now where does an APB really function? Well, I need to get these operators instantiated in the first place. I need to start up. I have nothing. I have an OpenShift. Now what, right? What would be really nice to me is you have your APB. The APB is incredibly simple, super straightforward. Really all it has to do is instantiate the orchestration operator. And then maybe you have other APB components that, like, every time I want to add an asterisk, well, it's an APB. I go and click on the thing that says, okay, create me an asterisk. And then all it's doing is writing a CR, is creating a CR for you. And now the orchestration operator says, oh, you want to add another asterisk, or I want to scale that asterisk. Now I know what to do. So really, from the viewpoint of the user adding another custom resource, it's just adding the resource with the metadata that can be presented and entered into a nice simple form on a web interface. And all the magic that's required that you would normally have to go, okay, I've added an asterisk, and now I gotta go to my documentation, and then log into the MySQL server, and write insert blah blah blah, right? All of that magic can be really dealt with for you just through a really simple, like, create me an asterisk, and I don't really care all the other things that go along with it, right? And then all you need to do is, when your business logic changes, or you find a bug, or you add an enhancement, you add that to the individual operators and maybe the orchestration operator, and then you lifecycle manage those operators with the operator lifecycle manager. So all of that stuff is kind of dealt with for you. I mean, that's kind of how I'm picturing this at these layers. Some of this may flatten. The orchestration operator may just be another operator at the same level as operators. I'm not entirely sure where all that fits yet, but that's kind of where I'm picturing complex, multi-component applications kind of being tied together that way. In some cases, like Doug had mentioned, you may not really even use operators, and this would flatten even further where the orchestration operator and all the other operators and the operator lifecycle manager really are just not even part of your structure, and it's really just APB and components.
Yep. Hey, Leif, quick question on this one, and maybe that explanation was great, thank you. But question, dotted line blue arrow from the orchestration operator to the component itself. So does that mean sometimes it might do a little bit more than just the asterisk operator itself?
So the reason I have that is, so let's say asterisk, let's say Digium Sangoma was creating an asterisk operator, and it was shipped with, it existed. I can grab it, right? I can consume it. I can leverage the things that operator provides me. But maybe my business logic doesn't work well with that operator. So maybe you just skip over, maybe your orchestration operator, you have some very specific business logic, and adding it to the asterisk operator just doesn't make sense, or leveraging that asterisk operator doesn't make sense. So effectively you throw it away and just directly interact with the container image.
Okay,
so,
I gotcha.
So you know what I mean? Like, you can mix and match where you have these things that exist, and you're like, okay, this thing doesn't work for me anymore, and adding functionality to it also doesn't make sense. Or maybe it's too complex, and I have a really, really specific niche thing that I want to do, and it's simpler just to build it at a higher level and interact with the container directly.
Okay, so just to make sure I'm picking up on what you're throwing down, I think it makes sense to me now, but okay, so asterisk operator, it knows all the smart things to do when you start an asterisk upgrade or whatever,
Yep.
But I have some niche business need. I use mod foobar, and I
Yeah.
want to say go ahead and module reload mod foobar,
Yeah.
because it's not appropriate for Asterisk operator to know about it. It's
It's my own
it's a
module,
niche
maybe.
case. It's just
Yeah.
for PBXs for beekeepers or something. So I'm gonna like just put it up there because it's not a generic solution.
Yeah, so
it's specific to that business.
Exactly.
Okay.
Maybe both of them exist at the same time. Maybe they're kind of layered. Maybe you just throw the Asterisk operator away and kind of move that logic up a higher level because you just have,
That makes sense.
So I can kind of sometimes see where maybe the operator that's shipped with the application, because the ideal is that, the Mongo people know Mongo really well, and
Yeah.
they'll provide an operator. The MySQL or MariaDB people will know their application really, really well, and they'll ship their own operator.
Yep.
And so ideally, these things kind of almost come as packages now, and the operator is kind of the application to a certain degree, or is it at least the interface to getting the applications up and running and configured?
Right, because
And-
that's like how we would use Prometheus today. Is we'd
That's
say-
exactly-
We'd say, I don't want to deal with the dirty work of all the different components that are necessary for Prometheus. I just want to say, Prometheus operator, go and set it up, and I just
Yep.
want to log in and see what the metrics are.
Yeah, all I'm doing is creating a Prometheus object of kind Prometheus into Kubernetes, and the operator goes and instantiates my Prometheus, configures it, and reloads it and all that stuff.
Cool.
This is kind of a question for you guys and probably anybody else in the audience as well. So over the years, we've been slowly but surely kind of trying to make Asterisk work a little bit better in sort of this operational model, which is obviously completely different than the operational model that existed when Asterisk was first written. We've done some own at Sangoma, we've done our own R&D projects around these things, so we kind of tend to approach it in a particular way. The question is, you kind of mentioned a lot of different things about, how you would go operator control Asterisk and things it ties into. What, in a containerized environment, what challenges are you guys seeing today? What things are still make Asterisk tricky, other than things that are outside of our control, like needing 30,000 RTP ports?
Yeah, and so, and on that note, I would just say that there's like networking considerations in Kubernetes that are still like burgeoning stuff.
That Doug's working on, like with Multis.
Yeah, so
Like
this
more
is,
than one network
This
interface?
is totally a offshoot here, and then I'll circle back around to what you've got that. But
You're controlling.
so I am currently working on an open source project that's called Multis CNI. CNI is Container Network Interface, and it's like a standard way to create interfaces in pods in Kubernetes. Today, when you spin up a pod in Kubernetes, you just have one UNO interface in there, which connects to your pod-to-pod network to talk to the other pods. So back in my telephony days, when we were doing stuff at scale, we had everything separated out on separate interfaces so that as we scaled up, we wouldn't get like UDP congestion, so that we'd have signal on one for SIP, we'd have media on another interface for RTP, and then we'd have management on a third one. So even if it
SSH connections, for
right,
example.
yeah, so I could,
So it's not overloaded from calls, and I can't log into the box anymore. So you have a whole separate network interface for management.
So this is like one like performance and scale kind of consideration for Kubernetes that I'm like actively working on, but there's other stuff that interests me for more than one reason, but a number one thing that interests me from it always being a problem for me is what Matt mentioned, which is it's difficult to allocate a wide range of ports to a container, to a Docker container, to a pod running in Kubernetes. And I have been tracking that issue for some time. And I wish that I had a good solution for it, but generally my solution is, if it works for your business case, use host networking, which is basically where you say, allow this container, which is intended to be isolated in its own way, right? It's meant to be namespaced and its own thing and not be able to see a lot, but you just say, this one's special, it's Asterisk, let it see all of the host networking. It needs to do big picture networking stuff, so let it see that. So that's what Matt, sorry to circle back around, but at least from my particular viewpoint, I would say that the push config stuff is really, really good for these dynamic type of things. I In creating these POCs, I did not, since I could like push in the configuration and essentially start with like my own like blank canvas asterisk and then mold it to my liking, that was great for me. And I have always felt that asterisk was fairly flexible anyways, and in my production asterisk days, there were never a time where I felt totally limited by what I could do, and maybe I did sort of had to like brew stuff a little bit, but I didn't find anything. But I would be really curious if anyone else has like run into these problems where they're saying, hey, there wasn't a good way to dynamically configure this, or I have scripts that works around this thing or whatever. I'm sure this is part of what Matt's looking for. That's not a terrible problem to have, Matt. I mean, it's like...
Yeah, well,
So how do you know what's going on inside your asterisk instance when you're spinning them up like this and spinning them down, right? So that's like the classic problem for me, right, is observability. You know, if there's an issue with a call and that asterisk instance gets blown away by its very nature, because that's actually what we want, how then do I know after that asterisk instance has been destroyed what happened in the call?
Yeah, and that's why we have like the capped agent or HEP or whatever, where you basically are always monitoring, you're always observing the pod, and always getting basically no logging lives on the pod. Everything comes out and goes centrally so that you can do assessments after it's gone away, because it effectively is, you have to think of it almost like it's a stateless application, even though it has state. And so its knowledge and what happened during its life cycle needs to be put out of it as soon as possible. So you use HEP or something, you know, I have all the calls that went through that particular instance. I have its status, I have its MOS score, I have, you know, all of that information. I have the SIP traffic that existed during it. It's all stored somewhere. All the logs, all the Asterisk console output, all the syslog stuff, you know, all that stuff has to be shipped out and put into our syslog or something like that, and it needs to be centralized and managed independently. So what you really need to do is keep Asterisk is just Asterisk. At that point, everything else peripheral of it needs to be peripheral of it. So you really need to think all the things that I'm running on a virtual machine right now, like our syslog and Homer and the database and all of those things, I really need to start separating all of those components out. So Asterisk is just Asterisk, and all it cares about is just dealing with call processing and logic. And outside of that, what happened and what's going on with it has to be pulled out of it immediately.
Something, and maybe this was in hallway talks that we were having, but something that you've got in Kubernetes is the idea of a liveness probe, which you can customize to say like, hey, I have this script and I run this command and I can use that to determine that this pod is alive or not. So in theory, I could make it do something like say, hey, query my monitoring system and ask how many calls I've had in the last n number of minutes, and if it's below this threshold, consider this dead, and I don't want to have this one anymore. So that's one thought. We are running out of time here. We're down to 1 minute. Thank you, Matt.
Want to allow people to go see Matt talk?
Yeah, you know what? Let's
all come up with some good questions for him too.
Yeah, let's wrap up so we can see Matt. Thank you guys for
Thanks everyone.
checking this out.
We'll be around, so feel free to come and chat and ask.